Okay, no? Hi everyone. So now we will discuss important concepts. Okay, subject is steel structure. Okay, so here for gate and engineering service students. Okay, students, in previous section already told weightage for gate. Hardly you will get one or two questions, that too numerical questions only. Okay, so but for engineering service prelims, this is a very important subject. Okay, you can expect 10 questions from this subject. Okay, but here you have to concentrate more on theory questions and the codal provisions. So 95% you will get the questions from codal provisions and theory questions only. Only 5% or one or two numerical simple questions, because calculator is not allowed for prelims. Okay, then students, for gate only numerical questions, right? Here I am not going to give any extra examples for gate people. Just revise the class notes sufficient, because only one or two questions. Okay, so here I'll concentrate only engineering service students. Okay, right, now we'll see the questions, okay, without wasting time. Right, but this is the questions not for gate people, for IS people only. I repeat students, gate people, just what are the questions I given in class, just practice those questions and leave it. No need to practice any additional questions. If you want to practice additional questions, just solve the test series questions sufficient. Okay, right. Now we'll see the questions. Right, first question. So this is the question from first chapter, that is introduction. Okay, right, here match list 1. In list 1 what is given? Type of section. I given various types of rolled steel sections, right? Okay, so these are the various types of rolled steel sections. Okay, and here in list 2 is given where we'll use this rolled steel sections applications. Okay, right, students, here ISJB, Indian Standard Junior Weight Beam, and MB medium weight beam, WB wide flange beam. Okay, and this is the T section. The students, these three are I sections only, right? Okay, these three are I sections. Okay, and I section also called beam section, right? And this is the T section. Where we'll use the ISJB? I given these points in class notes. Okay, for lentils will use ISJB. Okay, it means here it is A1. Next, ISMB medium weight beam. Where will use the medium weight beam? In buildings will use, right? Okay, so this is the B3. Next, ISWB wide flange beam. I told this is will use for in gantry girder. Okay, WB will use in gantry girder. That is nothing but in gantry girder only lateral loads at the compression flange level, right, is expected in gantry girder. Okay, so this is then C2. Then T sections in water tanks. Okay, then D4. Then 1, 3, 2, 4. Okay, so 1, 3, 2, 4. Then option D is correct. Right. Now we'll see the second question. Right. Now this is the second question. This is a question from second chapter, bolted connection. Okay, here identify the size and class of bolt having FIB. That is, what is FIB? Yield strength of bolt. Okay, FIB is yield strength of bolt, and the FUB is ultimate strength of bolt. Okay, and the given stress area. This stress area is nothing but net area. Okay, net area of bolt A and B. gross area of bolt, I given notation ASB, right? Okay, net area is A and B. Okay, right. Students, actually in the question this is not given. Okay, this box is not given, right? So here yield stress, this is FIB, right? Yield stress of bolt, and this is FUB. Okay, so what is given here? Yield stress of bolt is given 320 and ultimate stress is given 420. Okay, so this is the table given in IS 800 2007, right? Code book. Okay, so this is a table given in code book. Okay, now tell me 320. Now this is the 320. Okay, next 420. So this is for which grade of bolt? It is 4.8. So where is 4.8? Here and here, right? Then you can eliminate B. Clear? And you can eliminate D. Then either A or C, right? The next given, what this M18 represent and what M represent and what this 18 represent. I explain, bolt is designated, okay, by MDL, right? Yes or no? Here M represent metric size and D represent nominal dia of bolt. Okay, this is nominal dia of bolt. So this is the D, right? And this is length of bolt. Okay, so given, for example, this is the M20. So what 20 represent here? 20 represent nominal dia of bolt. Okay, right. Now tell me students, bolt grade we got. Okay, then here which grade it is? Is it M18 or 20? Here given stress area is 245. Okay, stress area is 245. Just I'll erase this one. Okay, I'll give the areas. Student, what is the formula to find the net area of bolt? It is approximately 78% to 80% of gross area of bolt, right? So what is the formula for gross area of bolt? I given formula here, will take 78%, then 0.78 times of pi d square by 4. So student, this value given how much? 245. Okay, this value is given 245. Then for which nominal dia of bolt will get the 245? Just here we have only two options, right? 4.8, 4.8, that is A or C. Just this is nothing but nominal dia of bolt. Okay, then in this formula 0.78 into pi, in place of D substitute 18 or substitute 20. Then check it for which case you are getting stress area is 245 mm square. Okay, so I think for M20 grade, nothing but for diameter of bolt is 20, then you will get 245. Okay, then for 20 mm dia, okay, for 20 mm dia you will get A and B is 245. I'll give the values here, just I'm erasing this one. Okay, so these are the values for all the diameters, for all the diameter. Okay, now these are the A and B value. Okay, and this is the ASB values, and these are the nominal dia of bolt. Okay, now here 245 is given, right? For 245, I mean for which bolt it is? 20. Okay, then here 20, then option C is correct. Okay, right. Next question. Right. So this is the question from second chapter, that is bolted connection. I given design formulas, right? Okay, what are the design formulas I given? Design shear strength of single bolt, design bearing strength of single bolt, and design tensile strength of bolt, okay, and design tensile strength of plate. Okay, these are the design formulas I given. Okay, now here first I given design tensile strength of bolt. So what is the formula for design tensile strength of bolt? Students, design tensile strength of bolt, it is based on cross section yielding, based on net section rupture, right? Okay, so what is the formula based on cross section yielding? Okay, based on cross section yielding, that is TDB equals to ASB Fi divided by gamma m naught. Now check it, is any formula is present here? ASB? No, here there is no ASB. It means this is the not based on cross section yielding. Then based on net section rupture. Based on net section rupture. What is the formula based on net section rupture? Just I'll write it in next slide. Okay, so here TDB 0.9 ANB Fi divided by gamma MB. Okay, this is based on net section rupture. Now check it, is the formula is present? So 0.9 ANB Fi divided by, so this is Fi, so this is FUB. Okay, this is FUB and this is FIB because bolt strength, right? Okay, right. Now check it, is the formula is present? 0.9 ANB FUB divided by gamma MB. Okay, so 0.9 ANB FUB divided by gamma MB. It means A3. Okay, A3. So here A, you can eliminate this one, you can eliminate this one, they can eliminate this one, then option A is correct. A3. Okay, you can check rest of formulas also. So what is the second formula? Design strength of bolt in shear. So what is the formula? Design shear strength of bolt, that is VDSB equals to FUB divided by √3 gamma MB NN ANB plus NS ASB. Yes or no? The students, in the question, if you won't mention threads are intercepting in shear plane or threads are without shear plane, intercepting in shear plane. Okay, this is with thread intercepting shear plane, this is without thread intercepting in shear plane, right? In the question, if you won't mention, always will consider threads are intercepting in shear plane only. It means in this case SS is 0. If SS is 0, then what is the formula here? Then FUB divided by √3 gamma MB NN ANB. Okay, then if it is a single shear, this is 1. If it is double shear, then it is 2. Okay, so in the question, so here we need FUB divided by √3 gamma MB NN into ANB. Okay, so which formula? B2. So here ANB FUB divided by √3 gamma MB. It means here NN value is taken 1 here. Okay, NN value taken 1. Then what is the design strength of plate formula? Again I given based on cross section yielding, based on net section rupture, right? So based on cross section yielding, what is the strength of plate? That is TDP. Okay, so based on cross section yielding, this is AG Fi divided by gamma m naught. Based on net section rupture, this is a 0.9 An Fu divided by gamma m1. So this is the formula to find the strength of plate based on cross section yielding based on net section rupture. Okay, so here 0.9 AnB Fu. Okay, this is the formula, right? Okay, so C1, yes, C1. The last one is design bearing strength of bolt. What is the formula? That is a VDPB formula. 2.5 KB dt Fu divided by gamma MB, right? So this is the formula to find the design bearing strength of bolt. Okay, so but in the formula it didn't given KB. It means it taken KB for example 1. Okay, you have to give the KB formula value, but KB is missing here. Okay, so D4. D4. Okay, right. Right, we'll see next question. Right, so this is the question from tension member chapter, assertion and reason, or statement 1 or statement 2. Okay, so read it carefully. Tension members consisting of unequal angles. Yes, I told always will prefer unequal angle sections only, not equal angle section. Unequal angle with longer legs connected, okay, and is generally preferred. Yes, always longer legs are connected, right? So this is the gusset plate. Okay, like this, for example. So this is gusset plate and this is the Indian standard angle section. Okay, now this leg is connected to gusset plate, right? Now this is connected leg and this is outstanding leg. Okay, outstanding leg. Okay, right. Students, always connected legs are longer legs. Can anyone tell why connected legs are longer legs and outstanding legs are shorter leg, right? I given these all points. Students, there is no effect of shear lag in connected leg, right? There is an effect of shear lag only in outstanding leg. Because of shear lag effect, there is a reduction in strength of tension member. Okay, it means outstanding legs are less effective in transferring tensile force. Okay, so this is the reason always connected legs are longer legs. It means longer leg is connected to gusset plate and shorter legs are outstanding leg. Okay, and here in connected leg stress distribution is uniform, right? But in outstanding leg stress distribution is non-uniform. If the stress distribution is uniform, then there is no effect of shear lag, then there is no reduction in strength of tension member. But if the stress distribution is non-uniform, it means there is an effect of shear lag, then there is a reduction in strength. Okay, now here strength reduced, right, because of this outstanding leg only. It means this connected leg take more tensile force and this will take less tensile force. Okay, so assertion is correct. Always will prefer unequal angle section, longer leg is connected generally. Okay, right. Now why longer legs are connected legs? Why not shorter leg? Already told. Okay, if you see in this diagram, so this is the stress distribution, right? Okay, then here this applied load taken by, so this is outstanding leg. Okay, this is outstanding leg and this is connected leg, right? Okay, this is connected leg. And what is this called? This is gusset plate. It means this is longer leg and this is shorter leg. Yes or no? Okay, right. Students, here stress distribution is uniform. So this is uniform stress, and here for connected leg stress distribution is uniform, but for outstanding leg stress distribution is non-uniform. Okay, so if it is uniform, there is no effect of shear lag for connected leg, but here it is non-uniform, there is an effect of shear lag. Clear? Right. Now we'll see the points here. Reason: when an angle tension member is connected with one leg only, yes, is connected with one leg only, the connected leg is more heavily loaded. Yes, I told there is no effect of shear lag in connected leg, then it can take more load, but this will take less load. Okay, and at the location away from the joint, stress distribution is more uniform. Yes, students, this is the joint, right? Bolted connection. If you see away from the joint, stress distribution is uniform, but at the joint or near to the joint, stress is non-uniform. It means there is a reduction in strength at the joint or near to the joint. Okay, right. Here, so more uniform, that is shear transfer legs in the transition zone. Okay, thus the component plates of the tension member, that is not connected directly to the gusset plate. Yes, this is not connected to gusset plate, right? That is the outstanding legs are kept shorter length. Yes, statement 2 also correct and explanation also correct. Why we are always prefer longer legs or connected legs? Because there is a more load. Okay, so connected legs take more load compared to outstanding legs. So both the statements are correct, and statement reason R is correct explanation of A, then option A is correct. Okay, right. Next, and these are the points I am giving here, what the points I explained, and these are the points already given in the classroom. Okay, so same points. Right. Now next question. Again, this is the question from tension member chapter. The rupture strength of net section is conservatively approximated as. So this is the approximation form, right, to find the tensile strength of tension member based on net section, right, based on net section rupture. Okay, there is one lengthy formula given, and instead of that lengthy formula I given this approximation formula. Now here, where alpha is the strength reduction factor, shear lag due to. Okay, now what is the alpha values? Is given list 1 and list 2. In list 1 is given number of bolts per line. Okay, and list 2 alpha value, that is strength reduction factor. Okay, so these are the values given. Okay, so students, tell me what is the alpha value? I told if the number of bolts less than or equals to 2. Okay, if the number of bolts less than or equals to 2, then alpha value equals to 0.6. Okay, if the number of bolts equals to 3, then alpha value is 0.7. Then if the number of bolts are equals to or more than 4, or just more than 4, or welding case it is 0.8. Only 3 values, 0.6, 0.7, 0.8. Okay, so here for 1 or 2 bolts, what is the value? 0.6. Then this is A1, A4. So where is A4? Then here you can eliminate this 2, A4. Next, for 3, Okay, here less than or equals to 2, this is 0.6. If it is a number of bolts are 3, then this is 0.7. Okay, for 3.7, then this is B3. So B3 means then option D is correct. Okay, right. Here and for 4 or more than 4, our welding case will use alpha value equals to greater than or equals to 4, then alpha value equals to 0.8. For welding case also it is 0.8 only. Then here there is a one more is given for the absence of reserve strength. What is the absence of reserve strength? Did you remember I given this reserve strength? What is the formula? Okay, right. Look here. This is the TDN formula, right? Based on net section rupture. Based on net section rupture. Students, why we are multiplying with 0.9? I given this explanation. Okay, so here for safety we are reserving 10% strength. It means we are how much strength we are considering? Only 90% strength is we are considering for safety. 90%, that is 0.9. Okay, so what is given? Reserve strength, it is 0.9. Then this is D2. So D2. Okay, right. Right. Next question. Right. So this is a question from compression member chapter. Okay, and a very important question, that is a maximum slenderness ratio values I given in tension member chapter and in compression member chapter. Okay, that is due to dead load and live load, or a reversal of stresses due to wind or earthquake load. Okay, I given these values, right? Okay, now check these values. Member carrying compressive forces due to dead load and live load, and live load also called imposed load, right? This value is 180. Okay, then A3 180. Here compression flange of beam against torsional buckling, this value I given, it is a 350, right? Okay, it is 300. Okay, next, member normally acting as a tie but not considered effective when subjected to possible compression. Okay, just this is a key point. Compression due to wind or earthquake force. Just remember this is a key point. Okay, so for compression that is 350. Okay, then next, a tension member due to wind or earthquake load, then it is a 250. Okay, so here option A is correct. So these are the values I given, and in code book. Okay, just I am showing these all these points once again. Okay, right. Now next question, and this is the question from compression member laced column. Okay, built up column, I given laced column and battened columns, right? Okay, so identify the false statement, nothing but incorrect statement. Okay, right. So here the inclination of lacing bar from the axis of the column should be in the range 40 to 70 degrees. Yes, is it right or wrong? Yes, angle of lacing is in between 40 to 70 degrees. What is the reason? Already given explanation. Okay, so it is correct, but he is asking false statement, incorrect statement. Okay, so if you want, I'll show this one in the diagram, 40 to 70. Okay, so this is the theta value, right? This is the theta. Okay, always will take the theta with respect to vertical axis, that is longitudinal axis. Now this is the angle of laced members, right? So this value is always in between 40 to 70 only. IS 800 2007 suggested. Okay, it is minimum is 40, maximum is 70. So don't provide less than 40, don't provide more than 70. And what is the reason? I give an explanation already. Okay, right. Then this statement is correct. Now second statement, the effective length of single lacing effective length of single lacing is the length between the bolts. I given length between the bolts, I given notation L1, right? Yes, okay. So for single lacing, it is a L effective length equals to L1 only. Yes, correct. And slenderness ratio is limited to 145. Yes. What is the maximum slenderness ratio for lacing member? It is 145. Then statement 2 also correct. Okay. If you want, I given this one here. Look at here. So effective length of lacing bar. Okay. So for a single lacing system, effective length equals to L1. What is L1? Distance between the inner bolts or inner weld. Okay. If it is a double lacing, what is the effective length? 0.7 times of L1. Then if it is welded case, also 0.7 L1. But he given this statement. Okay. Right. So statement 2 also correct. Now statement 3. For single lacing, okay, single lacing, thickness of lacing bar should be at least 1/48 of length between the bolts. Yes. Okay. And 1/16 of this length for welded connection. No, this is not for welded connection. Okay. This is for single lacing, and this is for double lacing. Okay, this is for double lacing, but here is given welded connection. This is for double lacing. So this is the false statement. Okay, this is wrong. Then option C. And based on the edge distance, consider the width of lacing bar should be more than 3 times the diameter. I given width of lacing member is approximately 3 times of nominal dia of bolt, right? Yes or no? Now I'll show this 2. Okay, right. Look at here. So minimum thickness of lacing bar. So if it is for single lacing, L1/40. If it is a double lacing, L1/60. But in the statement 3 given, for welded connection is given. This is for double lacing. Okay. And next, these are the minimum width values, right? Okay. So what is the value? Approximately 3 times of nominal dia of bolt. Okay. So here D also correct. Then incorrect statement is C. Right. The next question. Yes, Suraj Chowdhury, you are correct. Next question. So this is also a from laced column. Okay. Now check it. What are you asking? Again, identify the false statement, incorrect statement. Okay. Right. First, in laced columns, end tie plates are provided to check the distortion of the column section at the ends because of unbalanced horizontal force from lacing. Yes. So this statement is correct. But he is asking false statement, incorrect. So this is correct. Did you remember? Okay, students, this is called laced column, right? Okay, the plate is called tie plate and these are called lacing. Okay, now this is the top view. Here, these are the 2 channel sections. Okay, now if this if it is subjected to forces like this. Okay, if it is subjected to forces like this. For example, if this horizontal force is for example 10 kilonewton and if this is for example 20 kilonewton, and because of these 2 unbalanced horizontal forces, then this top, it will become like this, right? Because of this unbalanced horizontal forces, this top of the column, it will rotate like this, nothing but this is the distortion. So this is called shear deformation. Okay, so distortion is called shear deformation. Okay, so statement 1 is correct because of unbalanced horizontal forces from lacing. So to prevent the distortion, we'll use the tie plates. Okay, right. Then second statement, this slenderness ratio of the column component, okay, that is nothing but column, okay, in case of laced built up column should not exceed 50 or 0.7 times of slenderness ratio of whole column. Whole column means this is called built up column. This is the built up column. So statement 2 also correct. Where I given this statement? To find the spacing of lacing, I given this. Okay, to find the, there is one condition I given. I'll show that condition now. Now this is the condition I given, right? So to prevent the buckling of column component in between the lacing, the following condition must be satisfied. So now this is the slenderness ratio of column component. Okay, it should not be greater than 50 and should not be greater than 0.7 times of built up column, that is nothing but entire laced column. Okay, so out of these two, whichever is less we'll consider. And what is the spacing of lacing? So this is a condition I given, right? So 50, 0.7 times of lambda of whole column. Yes. Okay, so statement 2 also correct. Okay, 50 or 0.7 times of slenderness ratio of column as a whole. Now next, but we need incorrect statement. Right, see here, for the same configuration, okay, and end condition. End condition means maybe single bolt or more than single bolt or welding. End condition. Okay, for same configuration and end condition, laced column is stronger as compared to battened column. Yes. Okay, for same configuration, it means same section. We use channel section for lacing, channel section for battens, whatever it is. Okay, for same section and for same end condition, laced column has more strength compared to battened column. Yes, this is also correct. Next, D, the effective depth of end batten. Okay, effective depth of end batten should not be less than 3/4 of perpendicular distance between centroid of the main member. Main member is nothing but column member. Okay, students, I given effective depth. Two values I given for end batten and for intermediate batten. Here I given end batten. For end batten, it is D1 only. For intermediate battens, it is 3/4. Okay, it means this statement is incorrect. Then option D. I'll show these codal provisions. If you see these codal provisions, okay, now this is the effective depth he asking. Okay, and this definition I given, effective depth of batten. Okay, so here for end battens, what is the effective depth value? D1. Okay, and for intermediate battens, it is 3/4 of D1. Okay, for intermediate batten it is D1 only. Okay, so what is D1? Already I shown in the diagram. Okay, so what is given? Here it is for end batten he given 3/4. 3/4 is for intermediate battens. Okay, so statement 4 is wrong. Right. Right. Next. And parallel, I am giving here some additional data from this topic only. Right. Now next question. In a double angle compression member section, okay, double angle compression member section will prove economical. So we have to use double angle, that is nothing but built up section only. Now which case it is economical? He given 4 statements here. Unequal angles with shorter legs are connected. Okay, opposite sides of gusset plate. Okay, and unequal angle with longer legs are connected on opposite sides of gusset plate. I told always will prefer unequal angle section, longer legs are connected legs. and shorter legs are outstanding leg. So you can eliminate unequal angle with shorter legs connected. No, this is wrong. Not shorter leg. Then longer legs are connected. Okay. Unequal angles. Okay. Longer legs are connected. Okay. And equal angles. No. It is not equal angles. Always we prefer unequal angle section. Okay. So we can eliminate. Then out of only 2 are left, right? So unequal angles with longer legs connected on opposite sides of gusset plate, and here same side of gusset plate. Okay. The students, if you see this diagram, so these are rough diagrams, and same side of gusset plate. Okay, so this is option B, and this is for option C, given same side of gusset plate. Okay, so these are the longer legs. Okay, so these are the longer legs. Students, which one is economical? Students, for this case, you will get the radius of gyration is less. Okay, for this case, you will get the radius of gyration is less compared to this. If the radius of gyration is less, then moment of inertia is less. If the moment of inertia is less, then size of the section will reduce. If the size of section will reduce, then it is economical. He is asking economical. It means this is economical compared to this one. Then option B is correct. Okay. Right. So I am giving the explanation here why it is economical. Just I given one point here. Right. The next question. So this is the question from beam chapter. In beam chapter I given plastic section, compact section, semi-compact section, and a slender section. Okay, and these definitions I explained in plastic theory chapter. Okay, right. To class the outstand element of compression flange of rolled section. Remember, given rolled section and a welded section. Okay, welded section compact, and given a buckling ratio, that is width divided by thickness of flange. Okay, and ratio should be less than. For compact section he is asking. Okay, rolled steel section and welded section, for which case? For compact section. Do you remember these are the given in code book, right? Okay, so here outstanding element of compression flange. Okay, code book, these are table number 2, limiting width to thickness ratio. Width to thickness ratio. Table number 2. Okay, so given outstanding element of compression flange. Yes, this is the outstand element of compression flange. Okay, so here given this is the rolled steel section. Yes, this is the rolled section, and this is for welded section. This is for welded section. But which section given? Compact. Okay, so for compact, so this is given plastic, and this is given compact, and here is given for semi-compact. So given compact, right? For compact, if it is rolled steel section, this is 10.5 times of epsilon, and for welded section 9.4 times of epsilon. Okay, so first rolled steel section 10.5 times of epsilon, and for welded section 9.4 times of epsilon. Then option C is correct. Clearly mentioned, it is compact section. Okay, right. Right, and this is a question from beams chapter. Okay, I given design shear strength of beam section design formulas, and bending strength of beam section. In bending strength of beam section, laterally supported beam are given low shear case and high shear case formulas, right? Okay, so given low shear condition, okay, given low shear condition, the design bending strength MD determined by this the formula is given, and it is given a restriction for cantilever beam for simply supported beam, okay, and under service loads, the correct value of beta B, for following categories of section are given beta B values, right? For compact, for plastic and compact section, beta B equals to 1. Okay. For semi-compact section, beta B equals to ratio of elastic section modulus by plastic section modulus. Yes or no? Okay. Look at here. For plastic and compact section, beta B value equals to 1. Yes, it is correct. Okay. And for semi-compact section, beta B value equals to elastic section modulus by plastic section modulus. Yes, this is also correct. And this is for slender section. Yes, this is the elastic effective section modulus by plastic section modulus. This is also correct. Okay. Then all of the above. 1, 2, 3 are correct. Then option D is correct. This is a question from beams chapter. Okay. So these are the things I given in class notes. Right. Then next. So this is a question from again, this is a combination. Okay. First given, what is the formula for yield stress ratio? Just now in beam chapter we have yield stress ratio epsilon. So here this epsilon is nothing but yield stress ratio only, right? Okay, and I given yield stress ratio in second chapter bolted connection also. Okay, that is the maximum end distance 12 times of T epsilon, and same formula given in compression member chapter also. Okay, so what is the epsilon formula? Yield stress ratio, that is epsilon is yield stress ratio, that is 250 and the root of 250 divided by yield stress. Okay, then here A2. And non-dimensional slenderness ratio. What is the non-dimensional slenderness ratio? Formula 1. And design plastic shear resistance. This is nothing but, this is the design shear strength of beam section. Okay, this is design shear strength of beam section. Do you remember I give a notation V suffix D in beam chapter? Okay, that is AV, this is the shear area, right? Yield stress divided by root 3 into gamma m naught. Okay, then here C4. Then what is the shape factor formula? I give in plastic theory, it is the ratio of plastic section modulus by elastic sectional modulus. Okay, then shape factor is right. Okay, then here from this, what is the answer? C is correct. Okay. Right. Right. Now this is the question from plate girder chapter. Okay. The length of web of thickness of both sides of bearing stiffeners which act as a part of stiffener in compression is. Okay, this is a codal provision only, right? 20 times of thickness of web. Then option D is correct. So this is the diagram I shown. We drawn this diagram, right? So students, these are called bearing stiffeners, right? Okay, this is the bearing stiffener. I given two types of bearing stiffeners, right? Yes or no? One is load bearing stiffener, another one is end bearing stiffener under the concentrated load. Now this is the load given. Now this is called load bearing stiffener. Now at the end, that is at the support, it is called end bearing stiffener. Okay. Then students, if you see here, if you use the bearing stiffener, okay, some portion of length it is act as a stiffener only. Okay, some portion of web portion, it is act as a stiffener. So how much? Left side 20 times of thickness of web, right side 20 times of thickness of web. Okay, now if you see here, this portion will act, this is the web portion, right? This web portion will act as a stiffener only. How much length? That is 20 times of thickness of web. Okay, right. Next, so this is a question from gantry girder. Previous it is plate girder, now it is gantry girder. Maximum shear force in gantry girder carrying EOT, that is electrically operated overhead traveling crane. Two types of cranes are there, right? Another one is MOT, manually operated overhead traveling crane. Okay, occurs when we will get the maximum shear. Gantry girder will treat as a simply supported beam only. Okay, now when will get the maximum shear force? Students, if the wheel load, this is the ILD concept, if the wheel loads are near to the support, then reactions are maximum. If reactions are maximum, then shear force also maximum. It means at the supports will get the maximum reaction. If the wheel loads are near to the support or at the support, will get the maximum reaction. If the reaction is maximum, shear force also maximum. Okay, right. Do you remember, if a single point load moving from one end to another end, to get the maximum reaction RA, this is the ILD for reaction RA, right? ILD for reaction RA. To get the maximum reaction at A, we have to place the load where ordinate is maximum. It means if the reaction at A is maximum, shear force at A also maximum. It means if this wheel load is, if it is at the support or near to the support, then only we will get the maximum reaction and maximum shear force. So what the options are given? One of the wheel loads is at the support, then option B is correct, at the support. And one of the wheel load is at the midspan. If it is not at the center, you won't get the maximum reaction, that you will get W by 2 only. But if it is at the support, maximum reaction is W only. Okay, the option B is correct. Right. So this is the diagram I shown in class notes, right? In class. Okay. So these are the wheel load, right? Crab or trolley. If this crab or trolley, if it is near to this gantry girder, if it is near to the gantry girder, here will get the more reaction. If the reaction is maximum, shear force also maximum. Okay. Right. Now again, this is a question from same gantry girder. Okay. Identify the correct statement. Identify the correct statement. Student, a crane girder, okay, crane girder. So this is the crane girder actually. This is the crane girder. I'll take another color. Okay, this is the crane girder. And this is called, this long beam is called gantry girder. Okay, this long beam is called gantry girder. Now this is a front view. Now if you see from top view, now this is the top view, practical. And this will represent like this theoretically, like this. Okay, right. Now students tell me, this is a crane girder, right? This and this is the truss or nothing but a shaft. Okay, this is the shaft. We'll use the crane girders in industrial buildings to lift the or to transport the heavy load from one place to another place. Okay. Now here tell me, students, this is the length of the gantry girder, right? Nothing but this is the length of the shaft. Okay, this is the length of the shaft, along the length of the shaft. Okay. Now tell me here gantry girder, sorry, crane girder, is it along the length of the shaft? No, it is not along the length of the shaft, right? So what the statement is given? A crane girder spans between adjacent columns. Yes, these are the columns. Okay, these are the columns and these are the columns. Okay, and columns along the length of the shaft. No, it is not along the length of the shaft. This crane girder is not along the length of the shaft. Okay, so given correct statement. So this is the wrong statement. Then next, vertical forces transferred to the rails in case of gantry girder for EOT is 10% of maximum static wheel load. Students, for EOT it is 25%, right? This is a vertical force. Vertical force also called surge load. Three types of loads are there, right? In gantry girder subjected to three loads. One is gravity load, another one is vertical load, nothing but surge load, and third one is longitudinal load, also called drag load. Okay, so this is the 10%, this is wrong, this is the 25%, okay, for EOT. I'll show these points. Now look here. Vertical forces for EOT, how much percent it is? 25% of maximum static wheel load. Okay, it means statement 2 also wrong. Next, for MOT cranes, okay, for MOT cranes, maximum permissible deflection of gantry girder is L by span by 500. Yes, it is correct. I given these values, right? This is for MOT. I'll show these values. Yes, look at here. This is where the cranes are manually operated. This is MOT, manually operated. Okay, so what is the maximum deflection? Span by 500. Okay, so this is the option C is correct. And last one, gantry girders are always designed as laterally supported beam. Not always, students, not always. Generally, gantry girders are designed as a laterally supported beam, okay, if there is a no catwalk. Okay, what is the catwalk? I show the diagram. Right, now student, this is called catwalk, right? Now this is called gantry girder. Okay, this is gantry girder. Now, if this compression flange connected to column with the help of catwalk, then this gantry girder is designed as a laterally supported beam. Laterally supported beam. But if there is a no catwalk here, then this is designed as a laterally unsupported beam. Okay, so in the question given, always, okay, so gantry girders are always designed as a laterally supported beam. No, if catwalk is present, that is laterally supported beam. If there is a no catwalk, then laterally unsupported beam. Okay, so statement D is also wrong. Then only option C is correct. Okay, right. Right. Next question. The surge load in gantry girder are, is it gravity load? Surge load is nothing but, which load is? Lateral load. Okay, surge load is nothing but, students, vertical load I told, gravity load is vertical load. Okay, gravity load is vertical load. So surge load also called lateral load. Okay, surge load also called lateral load, and drag load also called longitudinal load. In previous case I told wrong. Okay, surge load also called lateral load. Right. So gravity load is nothing but vertical load. Right. Now tell me, surge load, it is lateral load. Then 2 is correct. So longitudinal also called drag load. Drag load. And gravity load is nothing but vertical load. Vertical load. Okay, then only 2 correct, that is B is correct. Okay, students, right. Then next, identify the false statement. In a double angle tension member with the angles on opposite sides of gusset plate, okay, the net area provided will be same for double angles on same side of gusset plate. Students, this is the gusset plate and double angle connected opposite sides of gusset plate and same side of gusset plate. Students, if it is opposite sides of gusset plate or same side of gusset plate, area won't change. Area is same only. Okay. So statement 1 is correct. Same area. So given double angle tension member with the angles on opposite sides of gusset plate, the net area, I given formula to find the net area. So how to find the net area? That is ANC plus AGO. This is a formula given, right, to find the net area of angle section. So this is the net area of connected leg and this is the gross area of outstanding leg. Okay. So next, B, the thickness of gusset plate should not be less than 12 mm. Yes, students, minimum thickness of gusset plate is 12 mm. Minimum thickness. Okay. So this is correct, but asking false statement. Next, the lacing used in built-up columns are basically tension member. Student, lacing and battening we studied in compression member chapter, right? Not tension member. This is the false statement. Then C. Okay, this is a false statement. This is not tension member. This is compression member. Lacing batten we studied in compression member, not in tension member. And no need to see the last one. Anyway, sag rods. Where I explain sag rods? In roof trusses, right? Okay. So this is the sag rod. So where will use the sag rod? This is called purlin. This is also purlin, right? Okay. So these purlins are interconnected with one rod, and this rod is nothing but sag rod. Now theoretically this is the example. So this is a purlin and this is a sag rod. What is the use of sag rod? To reduce the deflection of purlin and bending moment in purlin, we'll use the sag rod. This is the point I given. Okay. So students, these are the few important questions from important topics. Okay, for IAS people. Okay, students. Right. So students, I repeat. GATE people solve only numerical question because weightage is less. Only hardly you'll get 1 or 2 questions. But I didn't solve any numerical questions because all the examples I solved in class notes only. Just practice the class notes, not more than class notes. GATE people. IAS people concentrate more on theory questions and codal provisions. I given few examples. These are the examples. Okay, right. So students, shall I end the session? Okay, right. Thank you, students. Then again, all the best for your examination. Okay, right. Thank you.